This is Tech Math 2, and we're doing section 4-5 today. So 4-5 has to do with finding the midpoint of a line. So I've got some line, I have some XY plane, and I have some point X1, Y1. And I got some other point X2, Y2. And what I want to do is I want to find the midpoint. I'm going to call that A and B. So we'll have some line going through A and B. All right, and I want to go and find the midpoint of that line. Well, it would seem like I should come up and figure out where the midpoint is in the y coordinate. So I come up with where the midpoint, well, that doesn't look too much like the midpoint of the y coordinate, and then I should find the midpoint of the x coordinate, and where those two cross is the midpoint of the line. And clearly that's not the midpoint of the line, right? It's in a different spot than I have crossed, but that's going to be the idea. So we have a formula, and it says the midpoint in the x direction is going to be x1 plus x2 divided by 2. And the midpoint in the y direction is going to be y1 plus y2 divided by 2. But what happens if x1 is negative? I mean, I could be at minus 1, 1 right over here for my A point. Well, yeah, well, all that's taken care of, so it doesn't really matter. Positive or negative is not relevant. It'll all come out in the storm. You just put in the numbers and make it happen. Then we have to deal, so that's midpoint. Normally we just take out our tape measure and measure the stupid pipe and find halfway. That's the midpoint, right? That's what we do. The next thing we want to know is we want to know the distance between 2 points. So I've got an x1, y1, and an x2, y2, 2 different points, and I want to find the distance between those points. Well, because these guys are sitting on an xy plane, then the x's and the y's are orthogonal. O-R-T-H, orthogonal, misspelled, meaning they're at right angles. They're at right angles with each other. So because they're at right angles with each other, the distance between those 2 points is, this is A, that's B, this is C, that's my right angle. So C squared is equal to A squared plus B squared. We've seen that before, Pythagorean theorem. So now all I have to do is say, well, the distance between the points is going to be the square root of the change in the x direction squared plus the change in the y direction squared. And if I do that, then I'm going to get the distance between the 2 points. And all I'm doing is taking advantage of my 2 points are sitting on an xy plane, and the x and the y are perpendicular to each other, those 2 planes. Now, back to history for a moment. We call this xy dilly-dob thingy here, we call these Cartesian coordinates, right? Cartesian coordinates, after some French guy, and they're at right angles. Unfortunately, when Cartesian did these coordinates things, he didn't put them at right angles. His coordinate system was one that wasn't at right angles. It didn't become a right angle system until 100 years after his death. So 100 years after he dies, somebody else goes and says, oh, Cartesian coordinates, it'd be better if they had a right angle there. That would make things better for everybody, so we're going to do it that way. Well, that's not the way he had done it in the first analysis. Just what you needed to know, right? So remember that, whatever, even though you get a Nobel Prize and you end up having all kinds of really cool things happen in your lifetime for all the great things you've done, 100 years after you're dead, they could go and change it and keep your name on it. All right. So we'll look at number 2. And we have 4, 3, 2 points. 4, 3, minus 2, minus 1. And we want to find the distance between them. Okay, so I'm going to take x1 minus x2, x2 minus x1 squared, plus y1 minus y2 minus y1 squared. And let's say that's 6, square root of 6 plus 6 squared plus 4 squared. And at some point in the operation, we'd want to go and put it in our calculator, I suppose. Square root of 36 plus 16. Square root of 52. Square root of 52. And I'd put that on my calculator to get a number, but my calculator's in my pocket. It'd take a long time to get out. So I'm going to go and look at 52 and say that that's 2 times 26, which is 2 times 13. And I'm going to change this to 2, the square root of 13. We'd call that an exact mode. What is the name of this class? Anybody remember? Technical math, right? So in technical math, we don't leave things the square root of 13. Perfectly okay to do in a regular class, and if you do it in this one, it won't matter. I'll still mark it right. But I would expect an answer that was closer to way to go, stupid calculator. I've got it in math print. Okay, so at the square root of 52. So 7.21 would be perfectly okay. And then we'd say, well, you know, I really only have one lousy significant digit, right? So there's nothing wrong calling it 7. All right. Enough of that. Number 5. Okay, so we're going to look between 5 minus 2 and 1, 2. Okay, we're going to do it 2 ways. We're going to call this guy the x1, y1 guy the first time, and then we're going to go the other way the second time through. We're going to call this guy x2, y2, x1, y1. And what we're going to do is we're going to show we're going to get the same answer. We'd expect the same answer, but we're just going to show that. So the distance is square root of 1 minus 5 squared plus 2 minus a minus 2 squared and so it's the square root of 4 squared plus 4 squared, 32, and 32 is 2 times 2 times 2 times 2 times 2, so there's 2 square root of 4 square root of 2. All right, and we're going to do it again and turn it around. Distance is equal to 5 minus 1 squared plus minus 2 squared, and I have too many parentheses now, square root, and that's going to be 4 squared plus 4 squared is square root of 32 squared, which is still 4 the square root of 2, because 30 doesn't matter, right? I'll do it again. 32 is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So I've got 1, 2, 3, 4, 5 2's there. Square root of 5 2's. Way to go, 5, 2 to the 5th power. So I can bring out 4 of them and call it 4. And then square root of 2 left over. And what's my real answer anyway? Square root of 32. 5.66. So 5.66 would be okay. 5.7 would be okay. 6 might even be okay. Why not? Okay, are we convinced? We can go either way. Doesn't matter who's 1 and who's 2. Right. Don't have to do that anymore. Find the midpoint. Okay, so we'll look at number 10. So I got 0, 5, and I got 2 minus 4. And so I'm going to draw a graph. 0, 5, 1, 2, 3, 4, 5. 2, 1, 2, minus 4, 1, 2, 3, 4. It's almost. Oh, much better. Okay, well, the midpoint, because I go from 0 to 2, the midpoint has to be at 1, right? So 1, and I go 5 to minus 4, so the midpoint of that should be a half. So that's, by looking at it, if I draw a picture, that should be where my midpoint is. Now the math says the midpoint of the x-coordinate is the summation of the two x's divided by 2, which appears to be 1, and the y component would be the summation of the two x's divided by 2, which it would appear to be 1/2. And so use the math, draw a picture, either way works for me. Number 12. Uh, 2 minus 3, 4 minus 3. All right, well, we'll just write down the answer, right? The answer is 3 minus 3. All right. So I've got 2, 1, 2 minus 3. And I've got 4 minus 3. So I've got some line that goes like that. I want the midpoint, so it's going to be 3 minus 3. All right, now we'll do the math. The midpoint of the x guy, 2 plus 4 divided by 2. Wow, that's 3. I don't believe it. And the midpoint of the y guy, minus 3 divided by 2 is minus 3. Wow. I don't believe the math works again. The vertices of the triangle A, B, and C are given. For the triangle, find the perimeter, whether or not it is a right triangle, whether or not it's isosceles, and find the area if it's right. Well, why can't we find the area if it's an isosceles triangle? We ought to be able to do that. Okay, so we'll do both. Okay, we'll look at 18. All right, so I've got these points. Minus 6, 3. And minus 3, 7. and 1, 4. A, B, C. Now probably if we had a picture, this would be more clearer, right? So minus 6, 3, minus 3, 7, and 1, 4. All right, so assuming I do the picture okay, it would appear that maybe, just maybe, my right angle's there. Just maybe. All right, so this is A. With I'm in the wrong spot. See what I can erase. Erase, erase, erase. All right. Because it's minus 3, 7. So I have something that looks like that. Oh, wow, that looks more like an isosceles triangle than it does anything else. Okay, well, what do we need to know? We need to know the distance A to B. That'd be nice to know. Square root of A to B. Minus 3 minus a minus 6 squared plus 7 minus 3 squared. All right, so this is, that's 3 squared for 9, and 9 and 4 squared for 16. So this guy's a 5, because the square root of 25 is 5. And then we're going to look at the distance between B and C. Distance between B and C. So I got 1 minus a minus 3 squared plus 4 minus 7 squared. And look at that, we got the same thing. We got a 5 again. The distance between C and A. So we go square root C and A. So I'm going to go 1 minus a minus 6 plus 1 minus a minus 6, 1 minus a minus 6, 3, 4, 4 minus 3, squared, squared. All right, and then I've got 5 squared, 25, 26, square root of 26. Okay, so now the issue is, do I have a right triangle? What do we want to do? Oh, we want the perimeter. Okay, we'll go to the perimeter first. Perimeter. Okay, so it's going to be 2 times 5 plus the square root of 26. And we probably want that as a number 10. 10 plus the square root of 26. We'll call it 15.1. 15.1. No units. Okay, so that's my perimeter. Is it a right? It's obviously an isosceles triangle because I have 5 and 5. So now the issue is, can it be a right triangle? This guy's the biggest side. Is 5 squared plus 5 squared equal to the square root of 26 squared? If it were, then I'd have a right triangle. The answer is no, which implies not a right triangle. If I could spell right, which I can't, obviously. All right, that's better. Right triangle. So it's not a right triangle, but it is in fact an isosceles triangle. So part C, isosceles. Yes, because two sides are equal to each other. All right, now it says that I'm only supposed to find the area if it's right. But being the overachievers that we are, we're going to take this isosceles triangle and we're going to find that this side is the square root of 26. This guy's 5, that guy's 5. What's my height? And so if we could have the height, it would be okay. This is going to be the square root of 26 over 2, right? All right, so the height is going to be the square root of 5 squared minus the square root of 26 over 2 squared using Pythagorean theorem. And square root of 5 squared, also known as 25, minus the square root of 26 divided by 2 quantity squared equals 4.3. So my height is going to be 4.3, and the area of the triangle is 1/2 the base times the height. That is the height, dummy. All right. 1/2 the base times the height, square root of 26. All right, so I've got the height in my calculator. Divide by 2 times the square root of 26, and I have 10.965, 10.9659. And then I say, well, I probably don't have that many significant digits, so I'll just call it area is 11 and be happy with that. All right, so even though the author didn't want us to find the area of the isosceles triangle, we have everything we need to do it, so we might as well do it. Number 22. Find the equation of the line perpendicular to the line 2x plus 5y is equal to 12, and through the midpoint of AB, where A is minus 3, minus 4, and B is 7 minus 8. 7 minus 8. All right, so we'll do the midpoint first. The midpoint is going to be halfway between minus 4 and minus 8, which is a minus 6. Halfway between minus 7 and minus 3 and 7, which is 2.5. 2.5. 2 and 1/2. 10 divided by 2. No, 4 divided by 2. It'd just be 2. Yeah, I add them together. I get a 4. I divide it by 2. I get a 2. Okay, so now I know the midpoint. If I knew the slope, I would be almost done. So I'm going to take my equation and change it to y is equal to mx plus b, so I know the slope. So I've got 5y is equal to minus 2x plus 12. I've got y is equal to minus 2 over 5x plus 12 over 5. So I know the slope of the line I have is minus 2 over 5. But I want to be perpendicular, so the slope of the perpendicular guy is going to be minus 1 over the slope that I had. So minus 1 over minus 2 over 5. I invert, I multiply, and I get 5 over 2. Okay, now I know the slope of the curve I'm looking for. I know the point I want it to go through. So I look in the front of the book and I find the point slope formula in the front of the book. If I don't remember what it is, and it's y minus y1 is equal to slope x minus x1. All right, so I know all that, and I move down so I can see as much as I can at the same time. Y minus a minus 6 is equal to the slope 5 over 2 x minus 2. Y plus 6 is equal to 5 over 2x minus 5. I'm going to multiply everything by, well, I could just leave it in slope-intercept form and say final answer y is equal to 5 over 2x minus 11. I could do that. Or I could go and say, well, I'm gonna multiply by 2, and I'm going to have 2y plus 12 is equal to 5x minus 10. And then I have minus 5x plus 2y is equal to minus 22. And I could call that my final answer. So this is the general form of a line, and this is the point in the slope-intercept form of a line. And either equation would be perfectly okay because it didn't tell me which one they wanted. They just said, give me the equation of the line. Now you could be overly particular and say, well, they gave it to the original line was in the general form. My answer should be that way too. You could overthink the problem that way. I myself, I would not overthink it that far. Okay, let's look at 25. Now we'll look at 26. Yeah, all right, we'll look at 26. 26. A is at 2, 6. B is at 7, 2. C is at 8, 5. And D is at 3, 9. And the issue is this a parallelogram, yes or no? That's the issue. All right, so we'll go to 6, and we're there. And then we're going to go to 7, 2, and we're here. And 8, 5, and we're there. And 9, 3, 9, and we're there. And we have something that looks sort of like that. So chances are it might be. All right, so how are we going to tell that this is a parallelogram? Well, let's say this is A, that's B, where's C? C is there, and D is there. So we want to show that AB is parallel to DC, and that AD is parallel to AD is BC. Right, so if we can show that those guys are parallel, then I think we have a parallelogram. We may want to show that the distance AB is equal to the distance DC. We may, if we showed that, and we showed the distance AD is equal to the distance BC. Okay, now, do I have to show both of those conditions to have a parallelogram, or do I only have to show one side or the other? I think I have to show, let's say I had something that looked like this. Something that looked like that was crossing that way, where these two guys are equal, and then these two guys are equal. That would be this condition, right? But I don't have a parallelogram in that condition. So I don't care about that condition at all. Totally irrelevant. All I need to know is whether or not these guys are parallel. All right, so I want the slope of AB. AB. Okay, so change in y, 6, we'll call it 2 minus 6. 2 minus 6 divided by the change in x. 7 minus 2 gives me a minus 4/5. And then we want the slope of DC. Slope of DC. Okay, so change in y, 9 minus 5 divided by change in x, 3 minus 8, and that looks like a minus 4/5. So the longer guys appear to be parallel to each other because the slopes are the same. Then I'm going to look at the slope of AD. Slope of AD. Change in y, 9 minus 6. Change in x, 3 minus 1. So that slope appears to be a 3, a 2, a 3/2, 3/2. And then I'm looking at the slope of BC. Change in y, change in y, BC, 5 minus 2, 5 minus 2 divided by 7 minus 1. Okay, so that looks like 3/6. All right, what am I doing wrong? I don't know. I have no idea. All right, so BC, change in y, 5 minus 2. Change in x, 7 minus 8. Or is it 8 minus 7? 8 minus 7. 8 minus 7. 3/1. They're not parallel. They aren't parallel? So the answer would be no. No parallelogram. Which one are we doing anyway? 26. No. Parallelogram. All right, show of hands. How many believe that that's the case, that I did it right? All right, so I might have done it right. Yeah. What we're going to do is we're going to go and look for a graph. Go look for a graph. Okay, so there's the XY plane. All right. So our points are 2, 6, 2, 6, and 7, 2. And 8, 5. And 3, 9. All right. And then we're going to put in these guys. I got that guy. I got this guy. I got that guy. And I got this guy. And wow, that looks sort of like a parallelogram to me. Okay, so the slope of these two guys is 3 over 1, 3 over 1. And so I've got A, B, C, D. The slope of AD is equal to the slope of BC, and which is 3 over 1. Okay, now this slope here, change in y, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, so slope AD, 4 over minus 5, slope CD, that's a B. Up 1, 2, 3, 4 over 1, 2, 3, 4, 5 minus 5. They're the same. So from this analysis, we have they are the same, and yes, we have a parallelogram. All right, so now we're going to go back and see why we were so hosed in this guy here. So 4 minus 4 over 5 minus 4 over 5. Why is this not a 1?
3 minus 1 instead of 3 minus 2.
So this should be 3 minus 2 or a 1. And then we get a yes. All right, excellent. One more problem, 27. So we, given that we know the right answer is yes, we could solve it. Is that what you're trying to tell me? 27. All right, so I've got A, B, and C. Is this a trapezoid with one right angle? Okay, so I've got A minus 12, 8. B, 3, 2. C, 5, 7. D, minus 5, 11. All right, so minus 12 is way over there. 8 is about there. 3, 2. 3, 2, about like there. 5, 7. Probably like that. Minus 5, 11. Okay, so we have something that looks sort of like that. All right, so what is a trapezoid anyway? Any trapezoid is anything with 4 sides. Do we have 4 sides? Yeah, we do. All right. Do any of them have to be parallel to each other? 2 sides have to be parallel in a trapezoid, right? Yeah, 2 sides have to be parallel. So now the issue is, we need a better picture is what we need, right? All right, well, anyway, A, B, C, D. So if anybody's going to be parallel to each other, look, we're going to look at the we're going to look at the slope of AB. Okay, so change in Y appears to be a 6. Change in X appears to be a minus 15. And then we're going to look at the slope of BC. Change in Y, not BC, DC. Change in Y appears to be a 6. And this guy appears to be a 10. Or a minus 10. So it would appear that the longer sides are not perpendicular. What did I do something wrong? 8 minus 2 is 6. Minus 13 minus 3 is that guy. 11 minus 7 is 6. Minus 5 is minus 10. Okay, so those sides are not parallel. So now we're going to look at the slope of AD. 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 Okay, change in Y. 11 minus 4 is a 3. Minus 5 minus 12 is a 7. And then we're going to look at the slope of BC. Slope of BC. Change in Y. We'll go with 7 minus 2 is 5. 5 minus 3 is 2. All right. So no one's parallel to anybody, which is okay. The issue is, do I have a right triangle? And if I change this guy to, this can be 3 over 5, right? This can be 2 over 5 with a negative sign. And this guy can be 3 over 5 with a negative sign. Okay, so I look at him and him, and I see that they're reciprocals of each other with a negative sign. So AB is perpendicular to BC, right there. And I have a, therefore, yes. We have a trapezoid, because a trapezoid doesn't need anything. Does a trapezoid need a parallel sign? That's the issue. Some days I remember these things, and some days I don't. And it's not in that chapter either. Too many pages in my book. So it's a chapter 2 things. Okay, so there is a still in chapter 1. Still in chapter 1. Still in chapter 1, still in chapter 1. Chapter 2. Okay, triangles. Pythagorean theorem. Oh, trapezoid. Trapezoid is a quadrilateral with only one pair of parallel sides. Okay, so I have to have parallel sides. I don't. So the answer is no. It's not a trapezoid. That's no trapezoid. Okay, good enough? We'll take attendance and then move on to our next class. Oh, the bad news is no quiz this week because we don't have a Friday class. The bad news is no quiz the week after this week because we have a test scheduled for that day. Or do we? No, we don't. Oh, good. We can still have a quiz on the 28th. All right. Thought you were going to get out of too many quizzes.